Data flow graph. The data flow graph model is a graphical representation of the flow of data between different functional blocks or processing elements in an embedded system. It helps to visualize the data dependencies between the different components of the system and enables designers to optimize the system for performance, power consumption, and cost. In a DFG, the processing elements are represented as nodes, and the data flow between them is represented as directed edges. Each node represents a functional block that performs a specific operation on the input data, and each edge represents the flow of data between the input and output ports of the nodes. Here's an example of a simple DFG for an embedded system that performs image processing. In this example, the DFG consists of 3 processing nodes, A1, A2, and A3, and an input node, image, and an output node, result. The image node represents the input image to the system, and the result node represents the output of the system after performing the required processing operations. The nodes A1, A2, and A3 represent the functional blocks that perform the processing operations on the input data. The arrows between the nodes represent the flow of data between the input and output ports of the nodes. For example, the output of node A1 is connected to the input of node A2, and the output of node A2 is connected to the input of node A3. In this DFG, the input image is processed by node A1, which extracts certain features from the image. The output of node A1 is then processed by node A2, which performs some further processing on the extracted features. Finally, the output of node A2 is processed by node A3, which generates the final output result. Overall, the data flow graph model is a powerful tool for visualizing and optimizing the flow of data in embedded systems, enabling designers to create more efficient and effective systems. What is Control Data Flow Graph Model? The Control Data Flow Graph, CDFG, is a computational model used in embedded system design to represent both the data flow and control flow of a system. Unlike the data flow graph, DFG, which only represents the flow of data between different functional blocks, the CDFG also captures the control flow of the system, including the sequencing of operations and decision-making processes. In a CDFG, the functional blocks of the system are represented by nodes, and the data and control flow between the nodes are represented by directed edges. The nodes in a CDFG can represent either computational operations or control operations. Computational operations represent the functional processing elements of the system, such as arithmetic and logic operations, while control operations represent the decision-making processes, such as conditionals and loops. Here's an example of a control data flow graph represented in code. In this example, we have a CDFG that takes 2 inputs, A and B, and performs a computation to produce an output, result. The control variable, C, determines which computation to perform based on the result of the greater_than operation. The greater_than function represents the diamond-shaped control node in the CDFG. If the result of this function is true, the system executes the subtract operation to compute the value of result. Otherwise, it executes the add operation. Overall, this code represents a simple CDFG that captures both the data and control flow of the system, enabling designers to analyze and optimize system performance and ensure correctness.